Let's solve the 12th problem from the list Top Interview 150 from Leetcode. The name of the problem is insert, delete, get random in O of 1. This problem asks us to implement a randomized set where the insert, remove, and get random operations for this set should be executed in O of 1 time. So the way any problem which is asking for O of 1 time complexity works is that we must use extra space to store the state of the set so that we can perform these operations in the required complexity. Now for this problem, what I'm going to do is to use a hash map to store the positions of the elements in set and use a list to actually store the elements. Now the way it's going to work is that for insert operations, what we are going to do is perform a search if the element already exists. If not, add it to the last position of the list and store the position in the hash map. So for both this operation and this operation, the time complexity would be O of 1 because we are adding the element to the last position in the list. The time complexity is O of 1. We are adding an element to the hash map. For this also, the time complexity is O of 1. We are performing a search, so we are not iterating on the list and doing a linear search, but we are querying the hash map to check if the element already exists in the hash map or not. So for this hash map, the key would be the element itself and value would be position index. Similarly, the way we are going to implement the remove operation is first perform a search if the element exists or not. If it does exist, then we move the element to the end of the list and then remove it from the last and remove the element from the position hash map as well. So again, for this, for every step, the time complexity is going to be O of 1. And finally, for the random operation, what we are going to do is use the math.random function to generate index from 0 to list size and return the element. So that's how we are going to implement the random function. So let's go ahead and try to code this. So as said, let us quickly define a hash map and call this value to index map. This will be a new hash map. And let's also define a array list called list. So we have done this part. Now let's try to go implement the search function. Here what we want to do is if our value to index map contains the value already, then we don't want to do anything. We just return false. Otherwise, we add the element to the list and we also update the position of this element in the hash map. So let's do that. So val to index map dot put. Here the key would be the value of the element and the value would be the position of the element. So list dot size minus 1. We are doing this because we are adding the element always to the back of the list. So the index of the element which was just added would be size minus 1. And finally, once we have added the element, we can return true to indicate that the element was added. Let's try to implement the remove function now. So here also let's first do a search. So if value to index map dot contains key value, if it does not contain key value, then we can return false. One thing here is this should also be contains key instead of contains. So let me update that. And now if the element exists in the hash map or in the list, now we get the position for that. So val to index map dot get, and this will get us the position for the element in the list. Now what I'm going to do is to swap the current element at this position with the last element in the list. So I am going to use a collections default method. So collections dot swap the name of the list, then the position I want to swap it with. So position and list dot size minus 1. So this is going to swap the element which is stored at the current index with the element at the last index. Now, since we have modified the position of the last element with the current position, we also have to update the value in the hash map. So the current swapped element would be list.get of position, and then we have to update the value in the hash map for this element. So we'll say value to index map dot put. I'm going to go to swapped element and update it with the value position. And now we can remove the value from both the list and the hash map to finally perform the remove. So let's remove the last element from the list, and let's remove the last element, the position for this element from the hash map as well. So finally we can return true because the deletion of the element has been completed. Let's move on to the getRandom function. So here we need to first generate an index randomly. So random index is equal to math.random times the list size, and then we can say return list.getRandom index. This says this returns a double, so let's typecast this to integer, and this should be it. So math.random will generate a value from 0 to list.size minus 1. So we are covering all the indexes in random index, and whatever the value is getting generated, we are returning that. Okay, so before I submit this code, let's try to go over the code and see if we have missed something. And everything looks okay to me. And I think here this should be wrapped in a bracket so that this is returned properly. Now let's try to run this code. Okay, it runs properly. Now let's try to submit this, and the submission works. So in this video, we tried to solve the 12th problem from the list Top Interview 150 on Leetcode. In the next video, we will be solving the 13th problem from the list Top Interview 150.